Well, welcome to your first tutorial in physics. This is the beginning of your intro to dynamics. And in chapters 3 and 4, we had a pretty limited discussion when we studied kinematics, and it was pretty much just on how objects move. And we actually had a view that came from two main philosophers or scientists. So there's a few trains of thought that went into the 16th century. The first, I guess, view was by a guy named Aristotle. You've probably heard that name before. Now, Aristotle was only around 200 years, 200 BC, so he really played a large role in how things move. Now, if you think about it, at that time period, they didn't have cars, they didn't have trains, they didn't have any objects that were really moving horizontally. But what they did have was a whole lot of gravity acting on them, and that's what he primarily studied. So Aristotle believed that if you had two objects and one was twice as heavy as the other, the heavier object will actually move faster, or it'll hit the ground at a faster velocity. In fact, not only will it hit faster, since it's twice as heavy, it'll actually hit it twice as quick. So take for example these two objects. Obviously one at a much heavier weight, and he believes since it was at a heavier weight, that it should in fact fall quicker. And in this demonstration it does actually show it falling at a much higher speed. But was that the real reason? Now Aristotle was a bit of a philosopher, not so much of a scientist, so he never really tested any of his ideas. And it was probably about perhaps 1500 years before someone decided that maybe we should test out this whole idea of objects falling quicker. And so there was a guy named Galileo. You've probably heard that name before. And Galileo wasn't convinced that it was the mass that played such a role in the velocity at which objects fall. So instead, Galileo believed that the object's mass played no role whatsoever in the acceleration which occurred. So instead, he believed it was the air resistance that actually caused the object to accelerate quicker. So if in fact that was the case, then we could say that if you made the air resistance equal, as in took two objects of similar shape, and you dropped them, then they should fall at the exact same rate. As we see in this example right here, two objects of the exact same mass, or the exact same shape, a cannonball and a soccer ball, will actually fall at different velocities. Now, as it turns out, Galileo was a lot more correct than Aristotle. In fact, Aristotle was really far off, because if that was the case, then if you took two objects, here a car and a tire, and they were dropped at the exact same time, then the car should accelerate much quicker. Instead, what we see is the two objects, different air resistance, much different weights, and they actually drop at the exact same time.
So the biggest problem that they had with both those trains of thought was the fact that it was all about kinematics. It was how things move. What they couldn't explain was why do objects move in a certain way. In other words, why does an object accelerate as it falls down? Why doesn't it just maintain a constant speed? And then along came a guy named Isaac Newton, so another familiar name. And he was the first one that actually studied the causes of acceleration. He did this around 1642, right up until his death in 1727. And the connection between acceleration and its cause can really be summarized by three statements that Newton made about the laws of motion. And it wasn't until about 1665 that Isaac Newton's work on the laws of motion were first brought to light. And in fact, it wasn't until 1687 that they were actually published. And more than 300 years later now, his three laws are actually still which summarize the relationship between acceleration and its cause, which is force. So really force can be actually defined as simply being a push or a pull. Now in the next section we'll actually discuss Newton's first law of motion, but until then we'll leave you with that.